Let's talk a little bit more about benzene. If you have a benzene ring attached to a parent chain, so let's say I put it right over here. Then you name the benzene ring as a substituent. This substituent is now called a phenyl group. Phenyl. So if it's an alkane, we got 1, 2, 3, 4, 5, 6, 7, 8. So we have an octane, and the benzene ring is attached to carbon number 3, but we don't call it a benzene group. We call it a phenyl group. So this would be called 3-phenyl octane. Okay, but if benzene is the parent chain, erase this, and you have something attached to it, this would be bromobenzene. Okay. Now, if instead of the bromine, we have a methyl group, it's not called methylbenzene. It's given a whole new name, and it is toluene. So you need to know that. So a benzene ring with a methyl group attached is called toluene. If the benzene has 2 methyl groups attached, it's given a new name. 2 methyl groups attached. This is called xylene. All right, got to know these rules. So 1 methyl group attached to a benzene, it's toluene. 2 methyl groups attached to a benzene, it's xylene. Now you got to tell me where everything is, as in numbering. If you just have 1 substituent, you don't number. So like I did earlier, this is just plain old bromobenzene. But if you have 2 substituents, let's say you have 1 here and 1 here, then you need to tell me where the 2 bromines are. And you can see right here, this would be 1, 2. So 1, 2 dash dibromobenzene, all one word. Now with benzene though, they have this special type of nomenclature where if your 2 substituents are on carbons 1 and 2, you can use the term ortho, O with a line underneath. If the substituents are on 1 and 3, you use the term meta, M with a line underneath. If the substituents are on 1 and 4, you use the term para, P with a line underneath. So ortho, meta, para. So this over here, since they're on 1 and 2, instead of calling it 1,2-dibromobenzene, you can say ortho bromobenzene. Actually, we should probably write the dibromo because we got to make sure everybody knows that there are 2 bromos. Ortho dibromobenzene. So basically, the ortho just is in place of the 1, 2. What if you have something like this? Let's say I have a toluene and I put a bromine over here. Can you see that the toluene, this would be 1, 2, 3. So 1, 3 is meta. So what you could say is meta bromo toluene, because without this, it's just plain old toluene. But now that it's here, you don't have to tell everybody that it's on carbon 3. If you put meta, that immediately tells everyone that the methyl is on 1 and that the bromo is on 3. Okay, what do you think this is called? Remember, a benzene with 2 methyl groups is called xylene. So this is a xylene. But you want to tell everybody where the 2 methyl groups are. They're on 1 and 4, so it would be para-xylene. Okay, so that's the whole ortho-meta-para nomenclature. The reactions of benzene. Benzene does not behave like a typical alkene. So even though it has all these double bonds, as 3 of them, because they're constantly rotating, they're resonating, they're moving, they're delocalized, think of it that you can't catch them. And if you can't catch them, you can't break them. So we're not breaking any of the double bonds of benzene. But you can do a substitution reaction with the hydrogens, just like we did with the alkanes. So if I draw an expanded one out so that you can see what's going on. And we have double bond, double bond, double bond, and here's my benzene. And let's say I've got bromine. So we're going to do halogenation of benzene. But it's going to be a substitution reaction, not an addition. So we did the substitution back in with the alkanes. We can do a substitution with the aromatics, benzene. So remember, bromine is Br. All right. We're not breaking any double bonds. Why not? Because they're resonating. We can't catch them. They're moving. We're never going to break it. But what we can do is we can substitute 1 hydrogen with 1 bromine. And they're going to switch places. Remember what we did with the alkanes. You ended up with HBr gas, and the bromine hooks up here. Notice never breaking any double bonds. Okay? So this comes over here, this comes over here. It's a substitution reaction. So your final product is going to be a benzene with a bromine attached and HBr. What is this called? Bromobenzene. And then, oops, sorry about that, guys. This benzene with a bromine attached. And then this H came and hooked up with this Br, and you have a mono-substituted benzene, or basically it's a monobrominated or monohalogenated. Okay? All right, good. That pretty much wraps it up. Physical properties are the same as the other guys. They're a little oily, the benzenes. It's the chemical property that I mainly wanted to talk about. So that is it. I think we are done with unsaturated hydrocarbons. Obviously, you've got to read your chapters. Follow the what you need to know lists for the saturated hydrocarbons and the unsaturated hydrocarbons. Read the chapters, follow the videos, and then you will be all ready for your quiz. Okay? See you soon.